Yeah. Okay, good.
Hello. And today we're going to talk about how to add the first and the even numbers.
Okay.
Like 2, 4, 6, 8, and 10. And so on.
Yeah, okay. Okay, yeah, as you said. Hello, Mr. Eric. Hello, Mr. Ryan.
Hello, Mr.
Mr.
Hello, Mr. Flood. Yo.
Okay, so today our job is to sum the first and even numbers. Yeah. Remember, yesterday we talked about the sum of the first and odd numbers, and the equation is what? N times n, right?
Yeah. Square.
Okay, so n times n or n squared.
And right now it's gonna be n times n add n.
Okay, why is that? Okay, so I'm going to teach you. Yeah, this is the correct formula to sum up the first and even numbers. For example, there are 5, right? So the sum is 5 times 5 plus 5, that's 30. Am I right?
Yeah.
Is it 30?
2, 4,
10, 20, 30. Okay. So yeah, good question. Why? Okay. So why? Okay. So remember the first n numbers. Yeah, we're talking about the first n numbers. Sit down, please. First n numbers. Yeah, the sum. You know, in mathematics we use this symbol. Yeah, like a e. Ryan. Yeah.
What's that for?
That's e.
E-R-I-T-L-E.
E. It's e, and then you can say I equals 1 to n. Yeah, and then you can sum I. So that means I equals 1 plus 2 plus 3 plus till n. Okay. So basically, this is a mathematic symbol to say, okay, I want to sum I equals from 1 to n. Sometimes you can just say 1 to n. Okay. So let's like a sum. Okay. Sum from 1 to n. Sum I. So let's read. Okay. So what's this equation? Remember, what's the equation for this? Okay, so that's a quick way to understand it. Okay, so this sum is that the first item. What's the first item of this? We call it this number progression. Yeah, we call it all these R3. How do you spell this? Arithmetic progression. Okay, I don't know how to spell it. So the first item is.
And then spell math.
So like
1.
First item plus last item. Okay? So that equation. Yeah. First item plus last item times and how many items? How many? How many? And then divided by 2. Okay, so if you do this, the first item is 1. Yeah? The last item is how many items? Divided by 2. Okay, so this is the number. For example, 1 sum up from 1 to 100.
Have you put the alarm on?
No, I cancel it out. Yeah, from 1, look, 1 to 100 is 1 plus 100 times 100 divided by 2. So that's what? That's 50-50. Okay? Yes? 50-50. Yeah, you got it. To sum the numbers from 1 to 100. Okay. So now we know this. Yeah. Actually, we can use the mathematic induction to do this as well, right? Come, Ryan, don't touch it. We can do this mathematic equation.
Now we're gonna teach you about. Now here's a quick way to add 2 times 2.
No. Look. Okay, so when n base case mathematic induction when base case when n is 1. So let's sum.
N is 1.
Let it be 1, right? Because the first one number, yeah?
Yes.
Okay, so let's say fk equals, this is the 1 time k times 1 plus 1 times k divided by 2, okay? Yeah? And now we want to add one more item. So fk k plus 1 equals this, yeah? Fk plus what? Plus what? Plus what? Okay, don't touch it. No?
Plus k plus 1.
Plus k plus 1, exactly. Okay, so look.
Yes!
Look. This is the k. Because this is sum from the first k numbers. And then we want to plus one more, yeah? Okay? So look, if we substitute this in. So k plus 1 times k divided by 2 plus k plus 1, right? Yes?
Yeah.
And then if I put a 2 here, then this needs to be 2, right? Yeah?
Hey.
So this thing, so it equals to k times k squared plus k plus 2k plus 2, okay?
K square K.
Yeah, k times k is k
There's
squared.
K's
1,
and 2's there.
yeah, okay. So how do we simplify this? So, look, remember k plus 1 square equals k squared plus 2k plus 1, right? Yeah? Yeah? So look, k 2, and then I can, this 2 will be 1 plus 1, right? Yes? I take away this is k plus 1 square, and then take k plus 1. So what does it mean? This thing equals k plus 1 square, yeah? Plus k plus 1, okay? And divided by 2. And if I do the k plus 1, so that will be k plus 1 times k plus 1 plus 1. Okay? So what does it mean? This is n, this is n and 2. So it's the same form as k plus 1 times n plus 1 times n divided 2 by 2. Okay, so that means that this formula is correct, okay? So now, yesterday we already proved, so we don't need to prove it again. So this, remember, this is the sum of the first n numbers, right?
Yeah.
Yes? And we know the sum of the first n odd numbers.
Yes, which is square.
N squared, right?
N times n.
Yeah? So it means that if I do this is the sum of all n numbers, yes? And I
One of
minus the first n even all
one
numbers.
on the bottom.
All numbers. And what's this? What's this? That will be the first n even numbers, right? Because this is total numbers, and I deduct the even number, all number, that will be the even numbers, right?
Yeah.
Yeah?
Yeah.
Okay, so this is the formula we want to know. Okay, so this I just told you is this, right?
Yeah.
Yeah. Okay, so what's this? Look, that equals to n squared plus n minus 2n squared, right?
Yeah. What are you doing with splits?
Sorry?
What are you doing with splits? You're like this.
Oh, I think there's a problem. n plus 1 plus n divided by 2 minus, is it n squared first n even numbers? All numbers is n times n, right?
Yeah. What number is n times n?
Okay, so it seems that let's try. So let's start 2. No. Okay, so that will be that's a problem because how there's a slightly problem here. Okay, can you notice? Because look, keep quiet, Ryan. You make me dizzy. Okay. So please.
Spinning around makes you dizzy.
So let's first n numbers, yes? Yeah. So how many even numbers?
Up to n.
Okay, let's put it this way because look, because this n could be odd or could be even, right? Yeah. So how about let's say I want the first n odd numbers, yeah? Odd numbers sum is n squared, right?
Yeah.
Yeah. And then n squared plus the first x we want to know the first n even numbers, yeah? Right? And then it will be equals to 2n, not n, right? Because look, there are n numbers and then there are n numbers, there will be 2n, not an n, okay? Yeah. So that will be n will be 2n, so that will be 2n times 2n plus 1 divided by 2, right? Yeah? Because there are 2n numbers, not n numbers. Yeah? Yeah? This is sum of odd numbers. Yeah?
What?
N odd numbers plus n even numbers. How many numbers are there?
N.
N and n. There are n numbers, n odd numbers, and n even numbers. So how many numbers are there?
M.
2n.
2n.
2n. Because there are n, that will be 2n, right? Yeah, so that's 2n.
Why?
2n. You will now see the what? That's the sum of the. If this I put this is make it this is 2n, so that will be 2n and 2n plus 1. Yeah, divided by 4.
Why?
Okay, so 2 even numbers plus 2 odd numbers. So how many numbers are there?
Is a
One, two numbers, 2 even numbers. That will be 2, 4, right?
yeah.
2 odd numbers. That will be 1, 3. So how many numbers are there?
What do you mean 1, 3, and 2, 4?
There are 2 even numbers. That will be 2 and 4, and there are 2 odd numbers. That will be 1 and 3. So how many numbers are there?
4.
Yeah, easy. So that's 4 numbers. So the sum of this n is 2, right? So the sum of 1 plus 2 plus 3 plus 4 would be this formula. But we need to choose this n as 2n. Yeah, because there are 4 numbers. Yeah, got it. Okay, easy.
Yeah.
Okay, so now we just need to x equals what? So if I divide the 2, so that will be 2, right? So that will be what? 2n squared plus n minus n squared. Okay, so can you simplify this?
Wow.
2n squared minus n squared
N square.
plus n.
Yeah.
So this is the formula. Yeah, we just prove it. Yeah, that's the sum of the first even. Alright, first sum even numbers. Yeah.
I'll go do the coding.
Yeah. Wait. Okay. So now.
That's what exactly was it. N times n add n.
Yeah. So okay. So
Without
fn. Let's say fn equals n times n plus n. When n is 1, is the sum is 2, right? The sum should be 2, right?
2, 12.
Yeah. Am I right? The first one even number that will be 2, right?
2, 12.
Yes. Okay. So let's say fk again. K times k plus k, and then fk k plus 1 equals fk plus what?
2, 12.
So what's the what's the
K
next?
add 1.
No, because this is the look. If k is 1, right? f1 is 1, right? And f2 will be f1 plus the second even number. That will be 4, right? Yes. So this 4 is what? 2 times k plus 1, right? Am I right? K is 1, k is 2. K is 1 and k plus 1 will be k plus 1. So that will be 2 times k plus 1, right? That's why another one. F2 equals.
That's exactly what I meant.
F3 equals F2 plus what? 3 would be 2, 4, 6, yeah? So k is 2. 2 times 2 plus 1. So I want to add a 6. Okay, so it should be adding this 2k plus 1. Okay, so that equals what? K squared plus k plus 2k plus 2, right?
Yeah.
Yes? Am I right?
Yeah.
Is it
Yeah.
right?
Yeah.
Am I right?
Yeah.
Oh, you're touching that thing. Okay, don't touch it.
Now, next thing we're gonna do is the coding part.
No, we haven't proved this yet. So that would be, we want to prove is the same form of these, right?
Hey,
So
that's mine.
so that would be k plus 1, k plus 1 square. This will be k squared plus 2k plus 1, right? So how many will be left? If I take away this from here, then that will be another k plus 1, right? You see? We just proved fk plus 1 is k plus 1 squared plus k plus 1. So if we take this is k, so it's the same form of this n, right? So it's correct. Okay, so now I'm going to do a coding to implementation again. So you tell me which one is better, okay? Define fn.
Yeah, fine.
Answer, yeah, equals 0 for I in range.
Going really fast.
Range, the first even number is what?
2.
2.
4, 6, 8, 10, 12, 14, 16, 18,
The last even number will be 2 times
Forgot
n
22.
plus 1, right?
Yeah, that is.
then I need to spell as 2, right?
So as is
Answer what? Plus equal what?
plus equal will I.
I, yes. And return,
Oh yes.
return what?
Answer.
Okay.
Oh yeah. Ooh,
What's the time complexity of this one?
N.
Oh, n. Okay.
Next one is N. No N1. No N.
I haven't implemented it. How do you know? Okay, so the other implementation, Fn, return n times n plus n. Okay?
Oh, this one is better. Ooh,
Why?
Yeah,
Why?
yeah. Oh, quicker.
Why quicker? Because the time complexity is
One.
1. Because it doesn't matter which input, how big is your input. I can always calculate it in
Yeah.
constant time. Yeah.
And this one you have to do 2, 4, 6, 8, 10, 12.
Yeah. So okay, so look. Yeah, very good. Okay, so this return n times n plus n. Okay, in Python we have a formula from math. You can from math import import power. I believe is power. Maybe not. Maybe there's a function.
How?
No. I don't think there's. Okay, I will double check this. Maybe it's power.
How?
Power, then I can write power n2, right? So that means n to the power of 2, right?
How?
Okay, so
Ouch!
remember in Python, yeah, if you want to write a to the power of b,
Yes.
you can write it this way. A, guess what?
Guess what?
Times, remember, yeah, this times,
Why
yeah.
are you writing a star now?
star, that's a time, yeah, multiply.
Wait, last time you writing a dot.
Okay, that's okay. Multiply, yeah,
Yeah.
but I have to put another multiply b. So let's in Python, you can do it this way,
A
right?
times B.
It means a to the power of b. Okay, so if I do this, a 2 power 3, what's the answer?
8.
Okay, let's verify. Look here. Look here. Look, 2 times b, 3.
Can you see?
You see? You see?
Can you see?
8. Okay, got it.
Oh yes.
Okay, yes, okay.
How about this?
Okay, the last thing. Good job today.
Bye bye.
Okay, I'm gonna show the 2 times 3. Okay, look. This is the one I talk about. Okay, maybe can you hold it? Hold it for now. Let me check something. Okay, from math import power. Yeah. Look at this power function. Yeah. You can do it this way. Power 2, 3. It's the same thing. Yeah, it's the same thing. You see? Yeah, it's the same thing. Yeah. Okay. Thank you. Bye.